Students, so today we are going to discuss about the characteristics of sound. So how can you differentiate between two sounds? Okay, now there are three characteristics of sound, depending on which by which you can easily differentiate between two sounds, and these three characteristics are: the first is loudness, second is pitch or shrillness, third is quality or timbre. Okay, now before discussing about these three characteristics, so here we have an instrument. This instrument is called cathode ray oscilloscope. Okay, so what this cathode ray oscilloscope do actually, it shows us the wave pattern of any sound wave. So here you can see, so a microphone is connected with the Y input of this CRO. Okay, so in this output, actually this CRO has a screen just like your TV, but a very small screen. So in this screen, you can see this kind of you can see the wave nature of any wave. So it will in that screen you can see this kind of wave. Okay, so suppose you are speaking here. Okay, suppose in this microphone you are speaking here. So this CRO, it will show you the wave nature of your sound, wave nature of your voice. Okay, or suppose you are hitting a tuning fork with something, so that means you are creating some sound. So then this CRO, it will show you the wave nature of that sound. Okay, so wave nature of that sound means, using this wave nature, you can you can easily calculate the amplitude as well as frequency of that wave. Now this kind of waves, actually they are called sinusoidal waves. So these waves are actually, both these are called sinusoidal waves. Now there are another kinds of waves also. Okay, so one is just look like this. These are called sawtooth wave. Okay, there are these kinds of waves are also, many kinds of waves are also there. Okay, so these kinds of waves, they more popular, these kinds of waves are actually called sinusoidal waves. Now what is loudness? Loudness is the characteristics by which you can differentiate between a loud sound from a faint sound. So for example, if I whisper, then that means I am generating a very faint sound or a very feeble sound. Okay, but if I shout, that means I am generating a very loud sound. Okay, so the definition is, loudness is the characteristic by virtue of which a loud sound can be distinguished from a faint one, both having the same pitch and quality. Obviously, if two sounds have same pitch means same frequency and quality, then loudness is that characteristics which you differentiate between loud sound and a faint one. Okay, now generally loud sound has the high amplitude. Okay, large amplitude, but a small faint sound or a feeble sound has a very small amplitude. So how do you know? Suppose you have placed a tuning fork in front of this microscope, at this microphone, and this microphone is connected with a CRO. Now suppose if you hit with if you hit very slowly this tuning fork, then you will hear a very soft sound or a very faint sound. Okay, and if you hit this tuning fork very hard, then you will hear a loud sound. Now this CRO, if you see the wave nature of this two sound, then you will see that the loud sound has a very large amplitude. So here the second sound, this second wave, this one is the actually loud sound, and the first one is the faint sound or feeble sound. Okay, so from these two graphs, you can easily tell that the second wave actually has a high amplitude. Okay, but the first wave has a very small amplitude. So this shows that the loud sound has a large amplitude, but a faint sound has a very small amplitude. Now one thing you can clearly see, that the frequency of both the waves are same. Okay, so this is the wavelength of the first wave, and this is the wavelength of the second wave. So the wavelength of both the waves are same. Okay, and the frequency is also same. Okay, So that means loudness of sound depends on the amplitude of the wave. If the amplitude is large, then the sound is very loud. If the amplitude is small, then the sound is faint one or feeble one. Now intensity. Now actually this loudness is, it is the subjective nature. Subjective nature means the loudness depends on person to person. Okay, this loudness, it depends on the sensitivity of the listener. For example, suppose you are playing a music and the sound of the music is 100, suppose 120. You are playing a music whose loudness is 120 decibel. 120 decibel, you are listening a 120 decibel music. Okay, now for you this can be for you this music is very beautiful, but for a elderly person this music can be a noise. Okay, he cannot tolerate this kind of music also, because for him it is a noise, not a sound. So that means the sound depends on the person to person. It is depends on the sensitivity of your eardrum. Okay, sensitivity or um, of your eardrum. So this is actually this is actually subjective in nature. For you a sound can be very soft one, but for you, for other person, that same sound can be too loud. Okay, so that means every person has different sensitivity. Okay, now there are many kind of sounds that only teenager can listen, but an elderly person but a cannot listen that kind of sound. So every person has different sensitivity, and depends on the sensitivity, loudness also changes. So loudness is subjective. So that's why we defined another quantity that is called intensity. Now intensity is a totally objective nature. Okay, it is actually measurable quantity. Loudness is not measurable quantity. You cannot measure the loudness, but intensity is a measurable quantity. So what is intensity? Its definition is the intensity of a sound wave at a point of medium is the amount of sound energy passing per second normally through an unit area at that point. Okay, so what that means, suppose suppose if sound is playing in a music system. Okay, now imagine a 1 meter square area. Okay, 1 meter square area means length is 1 meter and breadth is 1 meter. Imagine a 1 meter square area. So the amount of energy passing per second, that means passing in 1 second, amount of energy, sound energy passing in 1 second through this 1 meter square area, it's called the intensity. So how much sound energy is passing per second in this 1 meter square area, it is called the intensity. So I am again the intensity of a sound wave at a point of medium is the amount of sound energy passing per second normally through an unit area at that point, and its unit is watt per meter square. Okay, now so obviously greater the sound energy carried, so if the sound energy greater the sound energy carried by a sound wave, greater is the intensity of the loud. Okay, so if the energy is high, passing per unit second, and a large amount of energy is passing per unit second, then the intensity will be large. Okay, now intensity depends on the some few things. First is the square of the amplitude of the vibration. Okay, square of the frequency of the vibration. Square of the amplitude of the vibration means if you increase the amplitude 2 times, the intensity it will increase 4 times. If you increase the amplitude 3 times, the intensity will increase 9 times. If you increase the amplitude 4 times, the intensity it will increase 16 times. So it proportional to the square of the amplitude, and it is also proportional to the square of the frequency of the vibration. And it depends on the density of the air. So if the density is large, then the intensity will be also large, and the velocity of sound in air. So I told you the subjective nature and objective nature. Loudness is subjective nature, but depends on the listener. But while intensity is a measurable quantity, it is an objective nature. I told you why it is a subjective and why it is objective. Now the factors affecting the loudness of sound. The loudness depends on five things. The first thing is the loudness is proportional to the square of the amplitude. Okay, so told you like intensity, loudness is also proportional to the square of the amplitude. So in the previous case, okay, what you see, we see that the if we increase the loudness, okay, if we increase the amplitude, then the loudness will also increase. Or in other way, you can say that a loud sound has a large amplitude. Okay, so obviously, if, so that means if you increase the amplitude, loudness will increase. So but actually it is proportional to the square of the amplitude. So that means if you increase the amplitude 2 times, loudness will increase 4 times. 2 square 4 square. If you increase the loudness amplitude 3 times, loudness it will increase 9 times, and so on. Lou- uh, Loudness, the second point is loudness varies inversely as the source of distance, as the square of the distance from the source. Okay, so suppose you are very close to a music system. Okay, music playing in the music system or a box. Okay, you are very close to that music system, then what you will hear, you will hear a very loud music. Now if you are very far from that music system, then you will hear a very less, okay, you will hear a less loud sound or a feeble sound. Okay, and if you are very far from that music system, then you hear a faint sound or a feeble one. Okay, so that means as the distance between source and the listener decreases, loudness is also increases. Distance between source and listener decreases, loudness increases. And as the distance between source and listener increases, loudness decreases. Correct? So loudness varies inversely as the square of the distance. Square of the distance. Okay. Next point is loudness depends on the surface area of the vibrating body. Okay, so that means if a object has a large area, then it will generate a loud sound, and if it has a small area, then it will generate a very soft sound or feeble sound or faint sound. Okay, for example, take your copy and your pen. Okay, now strike your hit your copy, the hit the flat surface of your copy with your pen. You will hear a then you will definitely hear a loud sound. Now again, in the second case, you hit the side of your copy, okay, copy or book with the same pen. Then in the second case, you will hear a very soft sound or a feeble sound. Okay, why? Because in the first case the area is large. Okay, the material is the same. Book is made of paper, uh, but material is same. But since the area is large, the first case you will hear a quite large sound. Okay, comparatively large sound. But in the second case, when you are hitting in the side, you will hear a very faint sound or feeble sound. Now third the fourth thing is loudness depends on the density of the medium. So as we increase the density, loudness also increases, and as we decrease the density, loudness is also decreases. So loudness is depends on the density. The last thing, loudness depends on the presence of the resonant body. So in resonance chapter, we have discussed this. Due to resonance, amplitude of the if two bodies have the same natural frequencies, due to resonance, okay, so due to resonance amplitude increases. So if due to resonance amplitude increases means, and amplitude is also proportional to the loudness. Amplitude increases means loudness will also increase. So that means the presence of resonance body near the vibrating body increases the loudness of sound. Okay, if there is any resonant body, then it will increase the amplitude, then that means it will increase the loudness. Now there is a relationship between loudness and intensity, and the relationship is loudness is equals to k log I, where this derivation is not in your syllabus. So L is the loudness, K is a constant of proportionality, and I is the intensity. And and the K log of 10, or log has a base of 10. Obviously you know that ln has a base of e, but log has base of 10. Base of log is 10. So L is equals to k log I. Okay, so this is the relation between loudness and loudness and intensity. So loud and intensity are proportional, but they are not directly proportional. So so in the next class we'll derive this equation for. So for today, thank you.